Welcome everyone to section 9.2, another identity section. Well, we'll be here for a while in chapter 9. And we're going to start with a little secret, okay? So I'm not going to introduce this section really. Let's just do an example. Let's call it example 0. And I want you to find the average rate of change. That's what this abbreviation is going to stand for. The average rate of change of a very simple function, y equals sine of x, on the interval from x to x plus h. So remember that average rate of change is just the slope. It's rise over run, okay? So it's the difference in the y values at these 2 points divided by the difference of the x values. Slope, rise over run, average rate of change, it's all this stuff. So this will be the function at x plus h minus the function at x all over x plus h minus x. No big deal. Easy stuff, right? So now let's plug in. What is our function? Plug x plus h into this function. We get sine of x plus h minus sine of x. Oh, in the bottom, something really nice happens, right? We have a plus x. We have a minus x. Gosh, they cancel. I don't know what that sound effect was, but we're here. Where do we go from here? Well, we've got a problem. We've got a big problem because these cannot be combined or simplified at all. Yet. Okay, we just found one of the reasons why we might want a sum and difference identity. We want to work with this. We're learning more tools. Chapter 9 is all about picking up more tools to help us during calculus, to help us during physics, to help us in more complicated biology applications. We need to be able to work and do more with trig functions. This is one of them. If you're curious, this is going to eventually lead to the derivative of sine of x in calculus. And we need a tool, okay? So we need 9.2 to go any further. Wow, how exciting. So let's introduce, not with an example, let's introduce sum and difference identities. And we're going to leave some space here. We're going to leave some space here for all of them. So the first one will be for cosine. We'll find out how to take the cosine of any angle, plus or minus. This will work for addition or subtraction, hence the sum and difference. Any other angle. We're going to be able to find out how to do that. We're going to be able to do the same thing for sine and the same thing for tangent. And I know it's a little weird that we write them in this order. Usually we say sine, cosine, tangent, because the cosine one's a little nicer. We're going to start with the nicer one. And now I hope all of you are at the edge of your seats just going, Jason, what is it? I want to know. Well, stay on the edge of your seat a little longer. We're going to figure it out together. Okay? So we want to find the cosine. So leave this blank. And then move on. So continue writing below this. We're going to actually find this. Let's look at the cosine of, let's actually start with the subtraction one. The cosine of some angle minus another angle. We're going to find out how to evaluate this. And we're going to do it with a picture. Okay? So it's picture time. I'm going to draw 2 pictures actually. So I hope you get ready for 2 pictures as well. So it doesn't matter where alpha and beta are. It doesn't matter which one's bigger or which one's smaller. But for the purposes of our pictures, I'm going to draw it this way. Again, it doesn't actually matter where we draw it. So let's say this red angle over here is angle alpha. Doesn't need to be bigger than beta, but let's have it be bigger. And let's draw a second angle that's going to be a little smaller over here. Let's say this is angle beta. Now visually, what does alpha minus beta look like? Well, visually, alpha minus beta is going to be this middle angle, right? What's the angle between the red and the blue lines? That'll be alpha minus beta. And we're looking for the cosine of this green angle. So what we're going to do is say, okay, let's not look at things tilted. Let's make this right, okay? And so let's copy this graph and draw this green angle over here. So again, this is where alpha was, and we're subtracting beta, so we need to be a little smaller than that. Maybe this right here is what alpha minus beta looks like. Okay, so now we have a picture like so. So now what's interesting is we can set up a system of equations here. All we've done is visualize alpha minus beta. We haven't done anything fancy here. This is how a lot of trig proofs come into play. Just drawing a picture and looking at what we have right here. So here's where things get really exciting. Let's look at the unit circle. Okay, so I'm going to try my best. Pretend that's a circle. This is our unit circle. And let's also draw a unit circle over here. So unit circle means each one of these lengths is 1. All right. So this is exciting. Watch this, watch this. What are the coordinates of this point on the unit circle? We know them. Remember, on a unit circle, the x-coordinate is the cosine of that angle, and the y-coordinate is the sine of this angle. So this is exciting. Watch this. Watch this. So this red point is the cosine of alpha, and the y value is the sine of alpha. Similarly, we know this blue point over here. The x-coordinate's the cosine of beta, the y-coordinate's the sine of beta. What about this green point? Here's where it gets, here's where you see where it's all coming into play. This green one is the cosine of alpha minus beta, and the y-coordinate is the sine of alpha minus beta. Ooh. So now you still might be wondering a little bit and saying, okay, Jason, I don't see how this is going to help anything. Remember is that these two green angles are the same. So I'm going to blow your mind. Watch this, watch this. Connect, hold on, let's draw a straight line. Connect the red and the blue dots. Connect the green dot with the x-axis. What do you know about these two yellow distances? Well, they're the same picture. One's just rotated, right? So these two yellow distances must be the same. Right? These are the same lengths. So the point connecting, the line connecting this point and this point, and the line connecting this point and, oh, we need to label something else, right? What's this point on the unit circle? This one's easy, right? Cosine of 0 degrees, sine of 0 degrees. The point 1 comma 0. So if these distances are the same, let's find the distances, set them equal to each other, and we're going to get a little bit of magic. All right. And that's what we're going to do for the rest of this video. If you really want to be a superstar, I recommend pause the video, try to find these distances, set them equal, and solve for the identity yourself. This is really good practice for anyone going into higher levels of math. You can set this up and prove it. Once I give you the outline, that's really, really good practice. And if you're still feeling a little uncertain, follow along with me. And then if you ever start figuring it out, pause the video and try to finish. Okay. Also, I'm sorry it looks like these have the same y coordinate. They're not supposed to. So let's call these two distances. Let's call this one distance 1 and distance 2. And we know D1 is the same as D2. They're the same distances. So what is D1? Well, we're going to need the distance formula. Remember, your distance formula is basically the Pythagorean theorem. The distance will be the square root of the x distances plus the y distances, like so. So what is the difference in the x coordinates? Well, that'll be cosine of beta minus cosine of alpha. All right, that's just how far is the x distance between these 2 points. And then we have the y distances as well. That'll be the sine of beta minus the sine of alpha. And we do something very similar for the second distance. Second distance, we also use the distance formula. Again, it doesn't matter which point we write first. That'll be the difference in the x's, which is cosine of alpha minus beta. Oops. Minus the x coordinate of 1. Plus, oh gosh, I did not give myself enough room to write. Plus the distance in the y coordinates, sine of alpha minus beta minus 0. Because there is no, the y coordinate is 0 for the second one. So we simplify each of these, set them equal. And it's going to be probably easiest to just work with and simplify each one on their own for a second. And then we'll worry about setting them equal at the end. So again, good algebra practice. If you want to take a moment, pause the video and see if you can simplify each of these. But what we'll get is this becomes cosine squared of beta minus 2 cosine alpha cosine beta plus cosine squared of alpha. And then again, I'm just working with one at a time. We have the signs as well. The signs are going to look the same. Sine squared of beta minus 2 sine alpha sine beta plus sine squared alpha. And now, lo and behold, Pythagoras is going to come in and save the day, because what have we got here? We have cosine squared of beta plus sine squared of beta. What's cosine squared of any angle plus the sine squared of that angle? It's just 1. Here, let's color code this. It's just 1. What else do we got? We have cosine squared of alpha plus sine squared of alpha. Thank you, Pythagoras. That's also 1. What's left over? That doesn't look as nice. That doesn't look as nice. But what's left over is we have minus 2. Let's factor a 2 out of both of these. Minus 2 times cosine alpha cosine beta minus sine alpha sine beta. Okay, that doesn't look so great, but I'm sure it's going to be fine. And actually, let's just combine these to a 2 right now. Oh, and then we could have factored out more 2s. We'll worry about that later. Let's simplify the D2. What's that second distance look like? Well, very similarly, we have to multiply this out. It's a squaring a binomial. First thing squared plus the last thing squared minus twice their product. So that becomes cosine squared of alpha minus beta minus 2 cosine of alpha minus beta plus cosine squared, whoa, no, plus 1. I'm not actually following notes for these. So if I make a mistake, I'm not going to figure it out until the end. We'll see. I haven't done this proof in a long time. Plus the other one is just sine squared of alpha minus beta. All right, this is easy. The minus 0 does nothing. And lo and behold, our good buddy Pythagoras, let's call him Pythag. No, let's not do that. sine squared of any angle plus cosine squared of any angle. Doesn't matter that the angle is alpha minus beta. It's just 1. So this becomes the square root of, again, 1 plus 1 minus 2 cosine of alpha minus beta. And that 1 plus 1, again, just combines to 2. Noticing anything cool? If not, you're about to. Let's check it. Let's check this out. Let's move it to a new page so I have enough room. So we know our first distance is this guy. We know the second distance is this guy. We can set them equal to each other. And what we do is we get 2 minus 2 times whatever. This is messy. I don't love this. But let's see what happens to it. And that equals the square roots, the second distance, which is the square root of 2 minus 2 cosine of alpha minus beta. What are we doing? We've done a whole lot of stuff. It's really important to pause when you're doing a long problem and just remind yourself, what's the point? Don't go into any existential crises or anything, but remember, what are we trying to do? We're trying to find a formula for cosine of alpha minus beta. We're trying to solve for cosine of alpha minus beta. We set up 2 of the same picture. We said these yellow distances are the same. And we're at this point. This is the guy we're looking for. Let's be consistent. This is what we want to solve for because we want a formula for that. We want an identity for that. And we know that this equation is always true. So if we square both sides, it's still going to be always true. Squaring both sides gives us this. Getting really sick of writing this middle guy. You are probably too. All right. And then lots of really nice stuff's going to happen. I'm going to take a couple shortcuts here. Don't look. So what we know is we can subtract 2 from both sides. That cancels. And we can divide both sides by -2 afterwards. It's by itself. What's left? We know that the cosine of alpha minus beta must equal cosine alpha, cosine beta. This thing I was really sick of writing turns out is our good old identity buddy. This is it. The cosine of some angle minus some other angle is just each of their cosines multiplied, each of their sines multiplied. Subtract them. Probably didn't see this one coming. That's kind of exciting, right? That's kind of cool. So this is our formula. We did it. We just came up with a formula all on our own. Well, you followed along with me and I had a little help. I needed to get the start as well. Okay, remember when I said if I make a mistake, I'm not going to find out until the very end? Well, I did. When we're over here and we're combining these two guys, what did I do? I factored out a -2, so we could simplify it a little bit. But if you factor out a -2, it's not subtraction anymore, right? If you factor out a -2, this becomes a plus. So this is a plus right here, which means that this is a plus, which means that this is a plus, which means our final answer has a plus. So very easy thing to fix, but very important. Watch out for that. So that gives us our first formula. Cosine of A plus or minus B is alpha cosine beta minus plus sine alpha sine beta. So what this means, right, is, and you can maybe color code this if you want as well. If you do plus or minus, if you use the plus inside the formula, you're going to get a minus on the right-hand side. If you use a minus inside, you get a plus. So this is just two formulas. Use both of the tops or both of the bottoms, both of the reds or both of the blues. It's a formula that tells you cosine of alpha plus beta uses the minus sign over here. Cosine of alpha minus beta uses the plus sign over here. Okay, so that's all that means. And we'll have similar formulas for sine and tangent, but you're going to have to wait for later. Let me know if you have any questions and have a good one.